Alright, so out of the diversity of subphylum Vertebrata, we're going to focus on the first three groups, class Agnatha, class Chondricthyes, class Osteichthyes. First guy that we're going to look at is this little dude. He's a conodont. He's an early vertebrate ancestor, notable in that it was a soft-bodied organism. What we know about it is it probably had muscular sides. There's evidence of ridging like muscles on the side. Pairs of eyes, probably a predatory feeder, no jaws or no evidence of paired fins. These guys are known primarily from little microfossils like those pictured up at the top left, which are conodonts, which means cone-shaped teeth. So they have these little structures in their mouth. There's like 3 different kinds of them that ring their mouth, and this is primarily what's found. Again, these are super tiny microfossils, not big animals at all, probably very eel-like. So now we get into modern fish. The first group of fish we're going to look at is the Agnathan. The A at the beginning means without, and Gnatha refers to the fact that it had no jaw, so without a jaw. Also did not have paired appendages, so there's no paired fins like we see in a lot of modern fish where they have pectoral fins or pelvic fins. The skeleton of this animal is cartilaginous, meaning it's made of cartilage, so it's not hard bone. They have a notochord or primitive support structure, so very similar to what we saw in some of the earlier chordates. 2 living examples of the Agnathans are the lamprey, pictured on the left. You can see some juvenile lampreys with their kind of strange round sucker mouths with all of their little teeth. And hagfish on the right. Hagfish are scavengers that feed off dead or decaying material in the water, versus lamprey being parasites where they actually attach to another fish usually and eat from them. The next group is infraphylum. Alright, so we're getting really obscure here with the prefix there, but this is just under phylum, Gnathastomes. This is the group that includes all hinged-jawed, paired-finned members of fish. They have a vertebral column that seems to have replaced the notochord. So they don't have that cartilaginous backbone. They have bones that make up a spine. The name Gnathastomes means jawed mouth. Again, we said Agnathan without a jaw. This means Gnatha, jaw, stomata, opening, or meaning mouth, referencing the mouth. There's 2 groups of Gnathastomes that we're going to look at, which are classified based on some characteristics that define how their skeleton looks primarily. We'll talk about those in a second. This is a typical Gnathastome, so unlike the kind of wide open lamprey mouth, we've got a definite jawed mouth that can open and close. Some other characteristics that we're going to see in some of these fish are fins. We learned some of the anatomical positioning names earlier in the semester. Anterior means towards the head end, so they have an anterior. Dorsal means backside, so anterior dorsal fin. Some of them will have a posterior dorsal fin, so there's 2 sets of fins. Very often if they have 2 sets of dorsal fins, the front one will have these really sharp spines. If you've ever gone fishing, be very careful. You can get stuck on those very easily. The caudal fin, that is the tail section of the fish, so the fin that they use a lot for propulsion. They will have often an anal fin. The anal fin usually is a single fin, unpaired fin. Then 2 sets of paired fins. Pectoral, which if you know anything about human anatomy, you probably know that the pectoral muscles are these muscles, the breast muscles. Those are the fins that attach to those muscles, and they also have pelvic fins, which is another set of paired fins that attach to the pelvic bone. Those are very close together in the fish. In us, they are separated from our chest to waist area. There's also a lateral line. We'll talk about what that means. There's a line that you can see running down the side of the fish. Very often there'll be a color difference between the top dark, bottom light, like we've seen in several other animals, and that usually is a transition right along this pitted line that runs down the side of the body. The operculum is a bony covering that covers over the gills in some fish, so we'll talk about that. The first of the two groups of gnathastomes is class Chondricthyes. Chondra refers to cartilage. Ichthyes is fish. So if you've ever heard of somebody that studies fish, a biologist that focuses on fish, they're called an ichthyologist. So Chondricthyes means cartilage fish. So the skeleton of these fish is made of cartilage. They are lacking some of the characteristics we'll see in the next group. They do not have a swim bladder, which is a organ used to maintain buoyancy in the water, nor do they have lungs, which may seem surprising that we're talking about lungs when it comes to fish, but we'll get there. So cartilage fish, there are about 1,050 species identified of Chondricthyes. Everything from sharks, which I'm sure you're familiar with many kinds of sharks, skates, which are kind of flat-looking chondrichthyans, rays, which are much larger chondrichthyans, but still flat, and ratfish, which look kind of like little mini sharks. Here's a typical example of a chondrichthyan, and if you count on here, 1, 2, 3, 4, 5, I believe, in this picture, 5 gill slits on the side of the head. So these guys do not have an operculum like we'll see in the next group, but they just have gill slits in the side of their head. So water goes in through their mouth, passes out through the gill slits, and when it's going through there, the gills are just inside those slits. And that's how they get oxygen out of the water. To give you an idea of size of some of these guys, the largest recorded great white was about a little over 6 meters in length. You can see that in comparison to a human. This is a human swimming up at the top left here, and that's the great white at the bottom. And you probably have heard of megalodon. Megalodon are extinct giant sharks. Some of them were up to 20 meters in length, proposed. The fossils that we found, somewhere between 15 and 20 meters seems to be the size of those. And now that's based not off of getting a complete skeleton. The skeleton of megalodon is cartilage. Cartilage doesn't preserve very well as a fossil, so primarily what we're basing this on is the jaw. The jaw is the hardest bony tissue in a shark, and very often that's the remains that you find. When a fish has an operculum, I told you guys that that was a bony covering over the gills. What you're looking at here is the operculum, and it's kind of pulled open, and you can see the frilly, feathery gills underneath there. So instead of having water go in the mouth and come out several different gill slits like we saw in the Chondricthyans, if they have an operculum, all the water funnels past all the gills and goes out one common opening. This bottom part, that has been cut away, so the operculum has been removed, and then you can see the full gill structures. Class Osteichthyes. These are fish with a hard bone skeleton. So when we say hard bone, we mean cartilage. That cartilage skeleton, part of it is that bony operculum that covers that single gill opening. They also will have either lungs or swim bladders. You probably don't hear a lot about fish with lungs, but there are some fish that do have lungs. This group, Osti, OS, just like we talked about ossicles and echinoderms, means bony. Osti, bone. Ichthyes, fish, so the bony fish. Most fish are classified as Osteichthyes. So if you've come across a fish in your world, you've had fish for dinner, it's probably from class Osteichthyes. There are 45 different orders of Osteichthyans. over 435 families, 28,000 species of Osteichthyes. So within the Osteichthyes, we've got two subclasses. The first is subclass Sarcopterygii, the ray-finned fish. They're called the ray-finned fish because you can see that their fins have nice little rays sticking out of them all the way around. 99% of bony fish are Sarcopterygians or ray-finned fish. The fins have webs of skin that support the spines. They're attached directly to the skeleton. So those are spines made of calcium carbonate that extend from the skeleton. So examples, Petocyprus is a 0.3-inch long fish, one of the smallest fish, if not the smallest, to the ocean sunfish, which comes in at a whopping 5,070 pounds, the long-bodied oarfish, which will top out at like 36 feet in length. So here are Petocyprus, tiniest fish, the ocean sunfish, and the long-body oarfish. So a wide variety of sizes and shapes, and they all have those common features of bony skeleton, operculum, spines that radiate out from the calcium carbonate skeleton. And that brings us to class Osteichthyes, subclass Actinopterygii, the lobe-finned fish. This is a much smaller group. Fleshy, lobed, paired fins are held to the body by a single bony stalk. They move like limbs. The fins evolved, we think, into modern tetrapod legs. And you can see from this picture the difference between those rays sticking out on the fins to a big lobe of flesh that actually has bones sticking out into it. And then they have some of those rays extended out from there. And those paired fins can function a lot like tetrapod legs. They have two separate dorsal fins. So the dorsal fin at the front, and then one that's got a little bony nub at the bottom that extends out at the back. Their teeth have enamel, so a hard coating that protects them from wear. Examples: there are only two known examples, the coelacanths and the lungfish. You saw in the video talking about chordate ancestry and looking at vertebrates that the coelacanth is considered a living fossil. For many years we only knew about it from fossil remains, thought that they were extinct. And then one day a fisherman, I believe off the coast of Madagascar, pulled one up in his net, and history was rewritten. This fish is still around. There's not a huge number of them, but they're still around. Here is an example of a lungfish, the other member of this group, the Actinopterygians.